the cathode. Okay, so we remember that the cathode is the negative electrode, so obviously we're going to get positively charged ions attracted to that. Okay, so when we start off with our positive ions, they're attracted to the cathode. The cathode donates up electrons, so we could draw a circuit. Looking at our circuit, okay, we could have one side is the positive electrode, one side is the negative. So obviously the negative is going to be my cathode, and the positive is going to be my anode. Okay, and then we're going to have ions in my electrolyte. Okay, some of those ions are going to be positively charged, and some of those ions are going to be negatively charged. Okay, so the positively charged ions are going to be attracted to the cathode, and then by deduction the negative ions are going to be attracted to the anode. So, we've got these reactions, we've got these positive ions being attracted to the cathode, and then we need to look at what happens to those positive ions. Once we know what happens to those positive ions, we need to look at how that actually happens. Okay, so first of all, what happens to the positive ions? So we can look at these reactions, and we can see, for example, in a reaction of the electrolysis of copper chloride, what we would notice in the negative electrode is we'd see it start to get a bit thicker, and that's it being plated with the copper. Okay, so what's actually happening in this reaction is somehow my copper ions are being converted into copper atoms, copper solid. Okay, remember that my ions are, oops, made a mistake. My ions are in the aqueous state, and my material that I end up with is in the solid state. Okay, so once we've looked at this, we need to look at how the copper ion gets transformed back into the copper atom. Okay, and to be able to do this, you need to look at what is happening to the subparticles in your copper atom. Okay, so we've got in our copper atom, we've got protons, we've got neutrons, and we've got electrons. Okay, and we can look in the periodic table and we can see how many, from the atomic number rather, how many protons we've got and how many electrons we've got. And then from the mass number, which is the bigger number next to the symbol, we can see how many neutrons we've got. Okay, so what I want you to do, pause the video and see how many electrons we have in copper, how many protons we have in copper, and how many neutrons we have in copper. We could see from our periodic table that the atomic number of copper is 29 and the mass number is 64. Okay, so I can tell from that the number of protons, the number of electrons, and the number of neutrons. Okay, so I know that my number of protons is just exactly the same as my atomic number. Okay, I know that my number of neutrons is the mass number minus the proton number. So I've got 64 minus 29, which is equal to, if my maths is correct, 35. Okay, and I know that because this species is uncharged, okay, the number of protons is going to be equal to the number of electrons. So I've also got 29 electrons. Okay, so in a copper atom we have the same number of protons as we do the number of electrons. So it's got a zero charge overall. Okay, if we look at a copper ion now, in this case it's going to be a 2+ ion, the proton number is exactly the same. still equal to 29. Okay, this time the number of electrons has changed. Okay, so I can tell you that each proton has a positive charge and each electron has a negative charge. So to get to 2 positive overall, I must only have 27 electrons. Okay, so how do we relate this back to our electrolysis? Okay, so if we go back and we looked at our cathode reaction, okay, we've got copper 2 plus ions in the aqueous state, and that is somehow going to make copper as a solid. Okay, now we can look at the number of electrons, and we know that copper 2 plus has 27 electrons. Copper as a solid has 29 electrons. So therefore, we need to gain 2 electrons to get to our copper solid material. Okay, and we could do exactly the same for the anode reaction. Okay, so looking at the anode reaction, at the anode my Cl minus was going to Cl2. Okay, so again, I need to look at my atomic numbers to work out the number of electrons in my chlorine. So chlorine has an atomic number of 17. Okay, chloride has gained an extra electron. So chlorine has 17 electrons. Chloride has 18 electrons. Okay, so it's gained an extra electron. So when we're actually looking at balancing what's happening at our anode, okay, we need to take it in 2 steps. So my first step is I need to balance the number of particles. So on my left hand side I have 1 particle, on my right hand side I have 2, so I need to multiply that by 2 to get my 2 particles. Okay, now once I've done that and we're happy at that stage, I can look at what's happening with the charges. Okay, so again, each of my chloride, I can look at the number of electrons. Each of my chlorides has 18 electrons. Each of my chlorines has 17 electrons. I have 2 chlorides, which makes a total of 36. I have 2 chlorines, which makes a total of 34. Okay, so I need to balance my electrons this time. Okay, so I have 2 more electrons on my left hand side. Therefore, I need to add 2 electrons to balance, to make sure I get the same on each side. Okay, so we can apply this to any reaction where there's electrolysis occurring, and we can look at a general rule. Okay, at my cathode, I always start off with a positive ion. It gains a certain number of electrons and it makes an atom. Okay, so in the case of copper chloride, it was a copper ion in the aqueous solution. It gained 2 electrons and made copper as a solid. Different positive ions will have different products produced. Okay, and then at the anode, I'm going to have a negative ion. Okay, and that's going to make my atom or molecule, which is neutrally charged. Okay, and I'm also going to produce an electron. Okay, so in my cathode, reaction. My electron is on the left of the arrow. In my anode, my electron's on the right of the arrow. Okay, so what I want you to do now is see if you can apply that to different reactions, different electrolysis, and different electrolytes that I've put up on the board.